So today we're going to be looking at angular frequency. So angular frequency. So in our equation, y equals sine of b times x. B is our angular frequency. So you've noticed, you've seen some examples, right? You've seen y equals sine of 2x. You've seen y equals sine of 3x. You've seen y equals sine of 0.5x. So in each one, there's an angular frequency, right? In sine of 2x, it's 2. Sine of 3x, it's 3. Sine of 0.5x, it's 0.5. So what exactly is angular frequency? So angular frequency tells us how frequently a cycle occurs between the angles 0 and 2 pi. So we're only looking at the angles between 0 and 2 pi. So for example, let's look at our first example, y equals sine of 2x. So here, example, y equals sine of 2x. Well, our angular frequency is 2. This tells us that this graph has 2 cycles. A full cycle happens 2 times between 0 and 2 pi. So here's our graph. So here's one cycle. And then another cycle. And that's at 2 pi. So between 0 and 2 pi, cycle happens twice. There are 2 cycles. All right? So the period of this graph is how long one cycle is. So we know 2 cycles is 2 pi. So in order to find out one cycle, we had to divide by 2. So period equals 2 pi over 2. And we have pi. So we know that one period happens after pi radians. Okay? And in general, the relationship between period and angular frequency is this. Okay? So period equals 2 pi, because we're looking at the distance, the length between 0 and 2 pi, divided by angular frequency. So angular frequency. And for short, we can just write that as P equals 2 pi over B. If we multiply B by both sides, so multiply B here, multiply B here, we can rewrite this as P times B equals 2 pi. So it's another way of writing it. So in order to find the period of a function, you have to look at 0 to 2 pi and find out how many cycles there are, and then divide to find out how much one cycle is. So period is equal to 2 pi divided by angular frequency. So here's a question for you. What is the period of y equals sine of 1/3 x? Period. We'll answer this in class tomorrow.